So Nata marathon is going on. So I will be taking a session on 3D composition, principle of composition right now for half an hour. Then for another half an hour, there will be a session by Nishitha ma'am. And in the end, there will be a session on arithmetic. So this is the flow that will maintain. And yeah, let me begin with my work. So now what we have to understand is like there are some kind of question which is called 2D composition or a 3D composition. So in these kind of questions, they might give you a word that may be like a watch or a penguin, and maybe you have to draw that watch or a penguin and create a composition which is appealing to our eye in some way. Here we need to figure out how we can achieve these things by using a principle of composition. So they can give you one element, they can give you element like banana, watch, and a penguin. Or they can give you a 3D structure. Right? This is the structure, and you have to use this structure and create a very nice and good looking composition. So how you can crack these kind of questions? So let me share my screen and show you some work and demonstrations so that you can understand how to crack these kind of questions. So ultimately, these are the approaches. For example, if the question is like there's a penguin, so you have to use a penguin to create a composition. So in these kind of question, what we have to do, first, there is no number of penguin which is written. So we can use any number of penguin. There is no restriction of size. So we can use any size of penguin. Third, there is no restriction of orientation that penguin need to be vertical, horizontal, or twisted, anything that we can do. There is no rule of overlapping that one penguin can overlap on another penguin. And the fifth one is colors. We can add any color to our penguin. So by keeping these five things in our mind, any number of time, size, orientation, overlapping, and the color, these things will help us to create a nice composition. So here you see there is a sense of focus. So these two penguins are really focused because they are in center, they are in highlighted color. Then you see other penguins, they are bigger in size, but in a lower opacity. Then you see a lot of penguin in a pattern, like there is a linear pattern. You see a penguin in a very radial manner. So how composing penguins in a different sizes in a different place, and it is also looking good to our eye. By using three colors, we have used just two colors, maybe blue, orange, and yellow. Three colors we have used. So this is one of the way to crack these kind of questions. Let's see different examples. Sometimes might give you object like electric bulb. Then what we can do? We'll apply the same formula that the bulb, any number of bulb, you can see any number of bulb, any size, any orientation, straight, tilted, overlapping, and different colors. So now you see there are three bulbs which is so big. So here also we have created a contrast, or we can say there is an emphasis which is going on this particular three bulb. Then when you see a lot of repetition, it becomes pattern. So you see a lot of bulb in a very harmonious pattern. So we can see two composition here very well, which is one is emphasis focus, like focus something, and the another is pattern. At the same time, there is a contrast because in terms of color. especially in the bottom row when we have used the color yellow and red. So yellow and red are not very, they are not mixing up with each other. So it creates a nice contrast. So the visibility is so high. And at the same time, you see another composition which is symmetry. Symmetry means that you put left and right weight equally. Whatever is there on left and right is more or less equal. So if we cut it from the center, there is a high chance that we will get equal weight on both sides. This is called symmetry. So we have included symmetry as well. Same thing can be done with the 3D forms. What if there is an abstract 3D structure and from that you have to play. So this is more of an asymmetrical approach, something which is not symmetrical and organized, little bit asymmetrical, and more or less we see there is a sense of hierarchy. Hierarchy means some is big, some is small, then it's very small. It's like ascending order and descending order kind of thing. And then we have used two color, which is red and blue, and that is kind of very contrasting with each other. So this is how we do 2D composition and 3D composition by applying some principle of compositions. Okay. So now I will try to give you a demonstration as well of the same thing. So let's start the Illustrator. So what if we have these shape with us? So let's draw one of the form. Okay, so I find this one interesting. Let's draw this one. So even if you are making one block, let's use one color, but by keeping a sense of lighting. So for example, let's assume that if the light is coming from here, okay, so this is the source of light. So we'll make this part really dark, okay, because here the light is not reaching. So let's use a blue color, maybe. Let's use a darker blue here. Here also light is not reaching, so we'll use the same color. This is the place where the light is reaching more. So let's use a light blue here. This is also a place where the light is reaching. So here also we'll use a lighter blue, definitely. And here also a little bit less. So we'll make it a little darker. Okay. We can make this surface a little more lighter. This also we can make a little more light. Okay. So now we have a block with a sense of lighting. Okay. Let's fix it a little bit. Okay. So now we have a nice drawing of a 3D block. Okay. What we have to do now, now the composition work begins. So how we can compose these things? Let's choose a background color also. And let's use something. So if there's a blue and you use a little bluish background also. Okay? Something like this. So then it becomes what is called, this is called monochromatic. Monochromatic means that we are using one color only, the different tint and shades of one color. If we use not exactly the same color, but a little bit similar, like little greenish, which is not very different. So this is called analogous, something in a similar zone. And if we use a very different color in the background, this is still not very far. Like, let's go with a little yellowish shade. Now, this one. This is too different from the blue. So now we have chosen a contrasting color palette for our design. Okay, but this is not looking very good. So we'll go towards a little orange. This is also not looking very good. Let's go a little more red. ठीक है. Maybe a little lighter. So now I think this color palette looks good. So let's see how composition rule we can apply. So composition says, for example, one composition is called balance. So in balance, what we do, so there is one form here. We take another form, we change the size, okay, and keep it here. Keep it almost here, and then also let's change the something, make it a little bigger, like this. So this is called balance, where the weight is equally distributed everywhere, more or less. I mean, we have more or less negatives, but in both sides it's empty. So it's kind of balancing it out. Okay. And so when you see a design where the weight is distributed almost everywhere equally, that is called balance. So this is, we have done balance. Now let's see symmetry. Symmetry is a version of balance, but symmetry requires more accuracy. So symmetry means that if you make a design like this and exactly, for example, let's make a design like this. This is interesting. So for example, if this is the design, okay, and we use the same design more or less on this side, like we reflect it. Okay, this. So when you exactly make something which is reflecting each other, left or right or top or bottom. So this is we call symmetry. So I'm also writing it here. ठीक है? Symmetry. Balance is more of a visually balanced, but it's not compulsory that it has to be geometrically calculated same on both sides. Visually, it should look that the space is balanced and the weight is everywhere. So this is called balance. Okay. Then we have symmetry. Let's see the another one, which is contrast. So contrast means when things are very opposite to each other. So for example, you put this one frame really big here, and then you put a lot of small things around it. So like this. So what we are doing here is like a two different world. One is very big, one is small, but too many people, but small group like that. So now it's a very contrasting world, especially in terms of size. We can also create a contrast on the basis of color. So maybe same thing, but mm, now the 3D-ness is going anyway. So either you can change the color very opposite, that becomes also contrasting, or you change the size, that also becomes contrasting. So contrast means which is very opposite to each other. Okay. So we have contrast. Now let's see another one, which is rhythm. Rhythm means when there is a pattern, when there is a flow, when there is a repetition. So how you create a flow when you repeat something in a very nice sequence, which is, so for example, you create a pattern, something like this. Okay, it becomes the interesting part. And now what we'll do, we'll try to repeat it. So when you make a design like this now, so what we are doing, we are creating a pattern. So pattern is what is a repetition of element. And when there is a pattern, that leads to rhythm. So it's rhythmic. There is a flow. There is a calculation. Then there is a, so it's rhythmic now. Okay. Now another one. Another one is hierarchy. So hierarchy means when you give importance to one thing, and then there is like main importance, secondary importance, tertiary, and giving importance step by step, and not everything is there. So when you keep a particular thing, okay, So for example, these two. So you understand, okay, these are something really important, and then you do this thing. So now what we are doing ultimately is called hierarchy, because it's like ascending order or descending order. We are giving more importance to something, a little less importance to another thing, and very least important to something. So when you maintain this sequence, this is called hierarchy of information. So I hope you are pretty much clear now. Ki the question can come from anything now. It can give you a random object, or it can be a combination of three random things, or one abstract uh, shape like this. But once you apply these principle of composition like rhythm, hierarchy, contrast, okay, okay, symmetry, balance, these things will enhance the visual appeal of the drawing. And it can overlap also. A one composition can be symmetrical and rhythmic also. So it's not like a composition rule can't overlap. They can overlap as well. But these are fundamental rules. Once you apply these kind of uh, thing in your drawing, anything that you'll compose, there is a high chance that it will be more appealing to the eye. So that you have to keep in mind. At the same time, keep colors also in mind. Are you using one color, two color? Here, what do you see? So this form is kind of monochromatic, that only one color has been used of the different shades and tint in blue. And then you see a background which is red in color. So color wise is already very contrasting. And when things are contrasting, the visibility increases. We can see something very bright and it's easy to perceive. So that is also one of the reason when we use contrast, especially in terms of color, it lead to focus. The focus increases because it's contrasting. It's not mixing up with each other ultimately. And as I told you, any number of times you can change the orientation, you can change the size. I haven't used overlapping a lot, but when one form is mixes up with another form like this, okay? So that is called overlapping. So this don't use it too much, but somewhere it might look good when it's not disturbing. So overlapping might work. And a part of it, sometimes what we do, a cutout. For example, if the part of the drawing is going out of the frame and you are just taking a separate part of it, and maybe, and if I show you, like, so here we are just seeing a part of my drawing. So this cutout is also allowed. That, for example, you're just taking a part of your element and showing it in a drawing. So that is also cutout, overlapping, size, any number of times, color and orientation. These things will help you to bring the variation. Otherwise, everything might look more monotonous, simple, and repetitive. So now, okay, guys. So this is how things need to be done, and I hope you are now clear how to crack these kind of questions. So now the another session is about arc awareness, okay, and that will happen from 7 to 7:30 by Nishitha ma'am, and from 7:30 to 8 p.m. there will be arithmetic session by Deependra sir. So this is how this whole Nata marathon will go on. I hope you will enjoy it, and I'm again sharing the Nata information in case if there is, because numbers are here if you want to contact anyone. So so here I'll end my session. Thank you all. I hope you have enjoyed it. Thank you very much. Bye bye. Good night.
Hello, am I audible? Good evening, students. Good evening, all. I am architect Nishitha Joshi. I hope that my audio is clear. So, I am here to take a session on architectural awareness for all of you. And today, like all our other live sessions, we will be having a discussion on one of the important topics related to your portion of JE paper 2 and Nata. And in today's class, I will be discussing about two topics that are integral parts of your syllabus of JE and Nata. I think there is some issue with my camera. I don't know. I'm trying to put on my camera, but it's not happening. So let me try to join from another device as well so that you all can see me. So as I was saying that in today's class, I am going to discuss about an important topic related to JE and NATA paper 2. So hello, good evening and welcome everyone. Is my PPT visible? Okay. Yeah, so as I was saying that I'm going to be discussing about two extremely important topics that are related to J paper 2 and Nata in today's class. So the first topic that we will be discussing in this class is bricks. So as you know that there have been questions that were asked in both J paper 2 and Nata related to masonry related to various building materials. So you can understand that this is a topic that is related to that, and here we are going to learn about various types of bricks, various brick bonds. Of course, we will discuss everything very briefly, and we are also going to learn about stone. So we are going to discuss brick and stone as a building material, masonry techniques that you can see in bricks, various type of bonds in bricks, and various type of masonry techniques that you can see with stone. So let's start. First of all, let's understand what is a brick. A brick is a building material used to make walls, pavements, and other elements in masonry construction. So this word masonry is a keyword here. In 2022 NATA, this question was asked that what is the form of construction that is done using bricks known as? And there were four options. The right answer was masonry. And similar type of question was there in 2023 JE paper 2, that what is the type of construction done using stone called, and the answer to that also is masonry. So you need to remember that the types of construction, various types of construction that are done using brick and stone, both are known as masonry. Traditionally, the term brick referred to a unit composed of clay. So you already know that brick is a traditional material, and it is a material that has been used in architectural construction for so many years. And the earliest kind of brick construction can be seen in Indus Valley civilization, which is also a common topic on which questions have been asked in the exams previously. So you know that there were mud bricks that were sun-dried bricks that were made in that era in the Indus Valley civilization, and all the houses, the great bath, the drainage system, so many other things, the granaries and everything was made in brick in the Indus Valley civilization. These were sun-dried bricks, and the type of bond was English bond. So you need to remember all of these are very basic things. We have already studied all of this in school, but there are questions that are asked on this topic in exams. It is now used to denote rectangular units made of clay bearing soil, sand, and lime or concrete materials. So, as time has moved on, the composition of brick has also changed. Now, brick is not just made out of clay, but there are many other materials. One of the most common examples that is being used nowadays is fly ash brick. Fly ash is actually a waste material, a byproduct that you get in steel and iron industries. So that is a byproduct out of which bricks are made. These are some common types of bricks. First is common burnt clay brick, then there is sand lime brick, fly ash brick, AAC bricks, hollow bricks, bio bricks, etc. These are just a few types. There are so many others like this, and there is a standard size that every brick has. So there are two types of bricks, traditional brick and modular brick. Traditional bricks were used earlier in load bearing buildings, and their size was slightly larger, not a lot, but very slightly. Um, but nowadays, the kind of bricks that we use for construction are known as modular bricks. These modular bricks can be made either with clay or with fly ash as well, or any other material. The standard size of modular clay brick is 190 cross 90 cross 90. Here you can see it is written 190 is the length of the brick in millimeters, 90 is the width in millimeter, and the height of the brick is 90 again in millimeters. Even if it is 19 by 9 by 9, then don't get confused, that will be the dimensions in centimeter. This is also a common question that has been asked multiple times previously, the standard size of a modular brick. Sometimes the in the options you will also find 200 cross 100 cross 100. Don't get confused, this is the size of a modular clay brick uh, in mm. That is also considering the thickness of the mortar that will be used to bind that brick. So 190 will be the actual length of the brick, but when you add the amount of mortar that is used to stick two bricks together, then that 10 mm is also added. So then it becomes 200 cross 100 cross 100. So that will be brick with mortar and brick without mortar. Just the brick is 190 by 90 by 90. So don't forget this. This is very important. And there are various classes of bricks. There are different materials out of which bricks are made. I'm just going to skip this because this is too much theory, which is not really required for Nata or J paper 2, but you will study about this in great detail when you actually join architecture school. So there are sand lime bricks, there are fly ash bricks, also known as FAB or fab bricks, which are becoming a common type of brick nowadays. AAC bricks, which are lightweight bricks, hollow bricks, which are bricks which have some cavity or some holes in it. Bio bricks, which are made with bio ingredients. And so now we come to different type of brick bonds. Bond means joining. So bond is an arrangement of bricks usually overlapping between courses. Bonding can also be used for decorative purposes of brick. If you want to make a brick jali or if you want to make a facade with some design or some arrangement of bricks, then also a creative type of bond can be used. Two of the most common brick bonds which are used to create walls. So there are different type of bonds that are used to create different type of wall. So two of the most common ones are English bond and Flemish bond. So here are some basic parts of a brick. This is also very basic, something that you need to know. So if you keep a brick flat on a surface, the side face of the brick is known as a stretcher, that you can see in this image, the side face of the brick, the stretcher. Then you can see in this image, you can see the header of the brick. You can see that when a brick is laying flat on a table, the smaller portion of the brick, the shorter side of the brick, that is known as a header. Then you can see the bottom part of a brick, which was earlier laying flat on the surface, that is the shiner. There's a row log there, the side portion when it is standing upward, known as the sailor, and the soldier. So these are the positions, different positions in which brick can be laid in a course. And there are different types of bricks depending on their shape and size. Some of the most common ones are king closer, queen closer, three-quarter closer, half bat. This is the king closer. This is the queen closer and the quarter closer. So these are some of the common sizes of bricks that are used for making different type of brick bonds, different type of pattern, jali, or different types of walls. Then there are different type of brick bonds. Brick bond means different ways in which brick can be attached with each other to create different portions of the structure. There's a stretcher bond, there's a header bond, facing bond, English and Flemish bond, which I told you are the most common ones, Dutch bond, zigzag bond, rat trap bond, etc. This is a stretcher bond where you just face all the stretchers in the front. This type of bond is used to make walls which are either garden walls, which are just boundary walls. Whenever you want to make a less thicker wall, which is not load bearing and which is not that strong, it is like a common wall. Then there is a header bond where the heads of the brick, they will be in the front, they will be in the facade. This is a thicker wall. If you have to make curved surfaces, then curved walls, then this type of bond is used. Facing bond, where the facings are in the front. The English bond, which was most common in load bearing walls. And the Flemish bond, which is most common in um, contemporary buildings in the frame structure. This is the Dutch bond, English cross bond, raking bond, in which the bricks are joined diagonally. The zigzag bond, where a zigzag pattern is created. You can also see an image on the right side how it looks once it is finished. The American bond and the rat trap bond. Rat trap bond actually has cavity in between the bond. So these were the different types of bricks and the different types of brick bonds. If you have any questions or any doubts regarding this, please let me know in the comments. I'll try to help you as much as you can. Some of the things I skipped because they were too much theory and not actually required for your preparation right now. But yes, the different materials of bricks, the different types of bonds, the standard size of brick, these are some things that you need to know. Also, you need to know about cavity wall. Cavity wall is a common type of brick wall that can be seen while uh, we are making insulated buildings. So cavity wall is actually a type of wall that has been questioned about a lot in both Nata and J paper 2. Multiple times there have been questions that what is the purpose of a cavity wall in a building, or what is the use of cavity wall in a building. Can you tell me what is actually a cavity wall, or what is the purpose of cavity wall in a building? If you know the answer to this, please write it in the comment section. I will check it and I'll get back to you. Let me see how many of you actually know what is a cavity wall. I've already given you a hint that it is used for insulation. So you tell me what is a cavity wall or what is its purpose in a building. This is actually one question that has been asked at least a minimum of 5 times. Totally, if I talk about Nata and J paper 2, this question has come across different years multiple times. So you need to know about that. I also want to tell you about our upcoming crash batches, which are going to be starting from 24th March, 26th March, and 31st March. The board exams are going on, especially all the 12 students are busy. So as soon as your 12th board exams are over, these are some batches that you can look forward to. You can join for these batches once your exams are over. You already know, students, that Nata papers are starting from 1st of March. Every Friday and Saturday there will be Nata exams starting from 1st March. So when you take your attempt after your board exams, these crash batches can help you with your preparation. You can see a contact number on your screen. You can call or WhatsApp on that number and inquire about our upcoming batches and join. If you want me to discuss all the topics of architectural awareness with you in great detail, then you need to join for our at length classes, because there we have 1.5 hours of time where we can discuss with each other and study in live classes, where we can also interact and learn about various topics. Now we will go to our second topic for the day, that is stone. So as I told you, we will be discussing two topics in today's class. So first one was brick, that we have already discussed. The second topic that I want to discuss with you in this class is stone masonry. So stone masonry is another type of masonry that is very common in construction, and that is also used very commonly nowadays as well. My first question before I talk about stone masonry, that where have you seen stone masonry? Stone is a material that is one of the oldest building materials of the world. Ever since human beings have started making structures, stone is one of the most common materials. From the earliest caves in which early men lived in, to the first kind of huts that early men made, all of them had stone in them. And even now we see so many places in India and around the globe where stone construction is so common. So my first question will be that, there are different types of vernacular architecture across the world. Where have you seen stone masonry? You have to tell me about this, that where can you see stone masonry? So stone masonry is made of stone units. Of course, the word stone is there. Stone units bonded together with mortar. Here, the word mortar is also used again and again. So, can anyone tell me what is the meaning of mortar? If you know, please write it in the comments. It is, I'll just give you a hint. It is a mixture. Now, what is this mixture composed of? I have already discussed this in my one of my previous live sessions. So you can also check the older video where we have talked about building materials. There I have discussed properly about mortar and its composition. You can either learn it from there, or if you already know it, please give me your answer in the comment so that I can check it. The construction of stones bonded together with mortar is termed as stone masonry, where the stones are available in abundance in nature. on cutting and dressing to the proper shape. They provide an economical material for the construction of various building components such as walls, columns, footings, arches, lintels, beams, etc. So from this we understand that stone is actually a very versatile material, and it can be used for the construction of entire building structure. It is not that any one part of the building can be made with stone. Just like brick, stone is also a very versatile material which can be used for construction of so many parts of the building. So, what are the different uses of stone? Let's just understand that quickly. It is used for making building foundations, walls, piers, pillars. It is used for making structural members of the buildings like lintel, beam, arches, domes, etc. It is used to make roof and roof coverings like roof tiles. Slate is a very common type of stone which is used for making slate tiles or slate roof tiles, roof coverings. Then for cladding work, cladding means you are overlaying an already existing surface with a new material to make it look more aesthetic and more um, you can say more appealing or smoothened or finished. For example, Taj Mahal, which is a brick structure. You might already be knowing this if you're preparing for Nata and JEE. Taj Mahal is actually made of bricks, but it is marble cladded. Marble is a stone that has been cladded on top of the bricks to give that beauty and appeal to the structure. Similarly, there are so many other materials. For example, with Victoria Memorial Hall, which is present in Kolkata, that is also cladded with white marble. So stone is such a material that can be used as a cladding material on top of any other material, either on some other rough stone or sometimes on top of brick, sometimes on other materials as well. Stone is something that gives more beauty, more strength, and a good covering that protects the inner structure from weathering effects as well. Like Sanchi Stoop, also it was made with brick. It was a brick dome, and then later on it was cladded with stone to cover it from the effects of weathering. Then, apart from buildings, also various other structures like dams, lighthouses, bridges, so many others can be made with stones. Then, paving pathways can also be made with stones, railway, ballast, blackboards, electrical switchboards, etc. There are many other uses of stone you already know. We select a particular stone or type of stone masonry in a region depending on various factors. First and foremost, the availability of stone in your local area, ease of working with that kind of stone, the appearance and look of that stone is very important. It should be strong and steady, it should be able to bear the load of the structure. Then polishing characteristics, whether it will look good or can it be polished or not. Economic factor is also there. The construction with that should not be very expensive, it should be affordable for the client. And of course, durability. Then here you can see a sketch which is telling you a little bit about stone masonry. As I told you, masonry is a common term that is used for construction that is done by either brick or stone. So here you can see stone masonry happening on site, and you can see various types of stones that are used here in this construction. Now let's understand classification of stone masonry. Now this topic is important because we have had questions on this topic previously in JEE paper 2 especially. So stone masonry is of two types. Okay, first one is rubble masonry and second one is ashlar masonry. When you listen to these words, they might sound very new and maybe strange as well, but they are actually very simple. In very layman terms, if I tell you, rubble masonry is something that is done with unpolished or very less pressed or less polished stones. Rubble masonry is slightly more, you can say, unorganized comparatively if you compare it with ashlar masonry. Ashlar is a type of stone which is very well dressed and polished, and it looks like a cuboidal block, just like a brick looks. Similarly, the ashlar stone blocks look like that. They are so well dressed, they are so well prepared before construction that they become very fine. They have very smooth edges, smooth surface, and they are proper like a cuboidal block, similar to a brick. So it is more systematic and more in order. Rubble masonry is also of a few subtypes. Random rubble masonry, where the stones are placed randomly, no particular like manner is there. You can say stones are of different sizes and a random arrangement is done. Random rubble masonry is also of two types. First is coursed and second is uncoarsed. Then there is square rubble masonry where the stones are comparatively squarish in shape. They are slightly dressed and made into square blocks. Then polygonal rubble masonry, flint rubble masonry, and dry rubble masonry. Dry rubble masonry is something that can be seen in villages where smaller structures are made, which do not have a lot of load, and where you have to make temporary structures also. In such places, dry rubble masonry can be used. Dry rubble means there is no mortar. The stones are actually standing there on their place because of the self weight. There is no mortar to attach those stones in place or to bind them, but they are just placed one on top of the other. Um, and they are standing there in their place because of the self weight of the stones. Then ashlar masonry also has a few types: fine ashlar masonry, rough tooled ashlar masonry, rock or quarry faced ashlar masonry, ashlar chamfered, and ashlar block and course. Of course, you don't need to remember each and every type, but majorly you need to know rubble masonry and ashlar masonry separately. So here you can see the coarse random rubble masonry. So here also the stones are very random in size and shape, but they are still constructed in some courses. So they will be laid in course by course. One course is laid, then maybe there is some divider or a thick layer of mortar or a stone slate or slab, and then another course will be there. Then again there will be a divider or a layer of mortar or something, and then again. So in this way, courses are laid. Here you can see that in the elevation, you can see three courses of coursed random rubble masonry. Now this is uncoursed random rubble masonry. So just like there were divisions here, there were separate courses. Here you cannot see any courses like that. These are uncoursed random rubble masonry. Then square rubble masonry, where all of them are not of the exactly same size, but they have tried to dress them a little bit and to make them into square or squarish blocks so that they can be laid more systematically as compared to the others. This is coursed square rubble masonry, and this is uncoursed square rubble masonry. Then this is polygonal rubble masonry, where the stones are polygonal in shape. They are not of any exact, like proper shape is not there. They are neither square or rectangle. They are comparatively more random, but they all have edges and they are forming some type of polygonal shape. That is why this is known as polygonal rubble masonry. Here you can see these gaps are there. This means that some water is filled in these gaps, which is keeping the stones bounded with each other. So that is polygonal rubble masonry. Then this is flint rubble masonry. You already know that flint is a type of stone. So in this type of masonry, stone used are flints or cobbles. They are irregularly shaped nodules of silica. The stones are extremely hard, but they are brittle and therefore they break easily. So obviously these are not used for making a solid or a permanent wall. It is more for temporary walls. Then this is dry rubble masonry. In this type of masonry, mortar is not used in the joints. This type of construction is the cheapest and requires more skill in construction, because here you have to manage to make this wall and to make it stand for a duration just by the self weight of the brick. So this requires more skill. This may be used for non-load bearing walls such as compound walls, for sheds, etc. Now we start with ashlar masonry. So as I told you in the beginning, ashlar masonry is something where you will have very finely dressed cuboidal blocks of stone, and they are almost looking like bricks because they are shaped like that. So here you can see ashlar, fine ashlar masonry. In this type ashlar masonry, stone is cut to uniform size and shape with all sides rectangular, so that you can see in this image. Now let's go to the next one. This is Ashlar rough tool masonry. So this is not as fine Ashlar masonry. In this type of Ashlar masonry, the beds are and sides are finely dressed, but the face is made rough by means of tools. So special tools are used to make the face rough. A strip about 25 mm wide and made by means of chisel is provided around the perimeter of the rough dressed face of each stone. This also creates a sort of texture on the face of the wall. Now, this is ashlar rock or quarry face. In this type of ashlar masonry, a strip of about 25 millimeter wide was made by means of chisel, and it is provided around the perimeter of each stone for rough tooled ashlar masonry. This is ashlar chamfered, which has chamfered edges on all four sides. Like you can see in the image on the right side, it is chamfered on the sides, creates a groove in the joint area between two layers of stone. Ashlar back and course masonry. So these were the different types of brick and stone masonry. Apart from that, we also studied brick bonds. So just like there is a fixed size of brick that is used for construction, there is no particular size as such when it comes to stone. The stones, as they are acquired, they are dressed in standard sizes which are easy to use. So as per ease of use, the stones actually are used for construction work. So there will be no standard sizes. Till here, if any questions are there, if any queries are there, please let me know in the comments. Okay, I have another question for you all. As you know that there are different types of stones that are used in construction. This is also a very common question that my students have asked me, that what kind of stone are what there are so many different types of stones available. How do we decide that what kind of stone should be used where? So first and foremost, it is very important to find out which type of stone is available in your locality, because that is the one of the most important criterias when deciding material for building construction. Local availability of material is the most important thing. For example, if sandstone is available in a good quantity, in good amount in my locality, then obviously sandstone will be seen more in my construction. For example, if you look at the forts of Rajasthan, be it Jaipur, Jodhpur, or Udaipur, you will find that different type of sandstone are used. Jaipur has more pink sandstone. It is a type of red sandstone only. It is discolored, and that is available in great quantity in that area. If you look at Jaisalmer, which is also another historic city in Rajasthan, there you will find yellow colored walls because their yellow sandstone is available in the nearby quarries. So for stone construction, it is actually very important to find out which type of stone is available in your locality. As per vernacular architecture, that is also one of the best kind of stones that is good for construction in your locality, whatever material is available around you. Secondly, you also need to understand the scale of your building, and you need to understand whether the stone that is available locally is right for that type of structure or that kind of construction that you want to do or not. So these are some basic criteria that architects take in consideration while deciding building materials like stone. There are many famous buildings that are made with stone. Can you name some of these famous buildings for me in the comments? I'll also give you some examples. One of the good examples is the Khajuraho temples, Nagar style temples that are present in um Khajuraho, which is a small town in Madhya Pradesh, very close to the capital city Bhopal. Then the Shore Temple, that is also a very good example of rock cut architecture, which has been constructed by cutting a natural rock. So it is entirely made with cutting one rock, and the entire temple is designed like that. Then the great living Chola temples, they are also constructed in stone, another very good example of stone masonry. Very good example apart from this of another stone structure monument is Amer Fort that is present in Rajasthan. Similarly, across India, in different states and different regions, there are many buildings which are made with stone. The type of stone may vary as per the availability from region to region. That is something that you need to notice. So after this session, please find out some more structures which are made with brick, which are made with stone, and try to learn more about them. With this, I am architect Nishtha Joshi. I'll be winding up my session now, and I'll be handling it over to your next faculty, Deependra sir, who will be taking your next session.
Thank you so much, Nishta ma'am. So, good evening once again, all the participants. I hope your sessions went really well on architectural awareness and drawing. And in this session, we'll be discussing aptitude. So we'll straight away get started with aptitude part. So I'll just share my screen so that we can start discussing questions. So this is going to be the flow of this session. I believe the screen is properly visible to all the participants. Just give me a thumbs up in the chat box if you cannot see the screen. With that, I believe you all have this clarity that aptitude means the basic mathematics which you must have studied up till 10th standard. However, in a little different, in a little, tricky manner, they ask you questions based on aptitude. So topics are still same, but they are a little, the language, they sometimes play with the language, sometimes they play with the numbers, sometimes your speed and accuracy is assessed. So this kind of thing is basically gets covered under the section aptitude. Questions are really simple, believe me. So if you are calm, you're patient, then you can crack a lot of questions with simple basic intelligence. For example, if you look at this question for the day, again, if you have any queries or concerns, don't hesitate in putting those queries in the chat box. Our team would love to answer those queries. Here we are with the first question for the day. If you look at this question, what does it say? If there is a number 18601x57y, and we are told that this number is divisible by 72, and you are asked the value of x plus y. Now, that may look a very tricky question, but please understand, if I could crack this 72 or split this 72 into a product of two co-prime numbers, for example, I think 8 and 9, because we know that 72 is nothing but what? 72 is 2 cube into 3 square. I hope this part is very well understood by all of you. So 72 is 2 cube into 3 square, which means 2 cube can be taken as 8 and 3 square can be taken as 9 here. So with that, I can treat 72 as 8 into 9, which means 8 and 9 are two co-prime numbers. Now, if 8 and 9 are two co-prime numbers, I need to ensure that any number which is divisible by 8 and 9 both will be divisible by 72 as well. I hope you're understanding the language very clearly, that whenever I want a number to be divisible by 72, I need to ensure that its co-prime factors, 8 and 9, if a number is divisible by 8 and 9 both, it will be divisible by 72 as well. So that is how you develop the divisibility rules. For example, had I been given number 24, now how do I develop a rule for 24? So 24 is nothing but what? 3 into 8. So I could have said that 8 and 3 are two co-prime numbers. I hope you understand co-prime. Co-prime number means that there is nothing common between these two numbers. That means their HCF should be 1. If you take the HCF of 8 and 9, it will turn out to be 1. I hope that part is very well understood by you all. So this is how you take or consider things. Now, I want this number to be divisible by 9, let's say first. Now, how do I ensure that this number is divisible by 9? I hope you know that some of the digits of a number should be divisible by 9. If that is happening, then we can say that the number will also be divisible by 9. Now, I know 8 plus 1 is 9, so I'll discard it. Then 6 plus 1, that is 7. 7 plus 7 is 14, and 14 plus 5 is 19. So 19 up till 18 is divisible by 9. So I'll be left with remainder 1. I hope you're getting it very clearly. So I'll be left with three things. One is the remainder, x and y. So now I need to ensure that x and y being digits. I hope you know x and y can be any digit from 0 to 9. So 0, 1, 2, 3 up till 9. It can take these two numbers, these two digits x and y can take any digit out of 0 and 9. But What I need to ensure is that sum of these two digits along with this one should be either 9 or a multiple of 9. So let's try and have it as 9 first. So to have it as 9, I can have a lot of choices here. So a lot of choices can be worked out here. Can it be 18? Now, in order to make it 18, I need to have, something around, let's say the minimum possibility. If I, keep both the numbers equal, it should be 9. And so a lot of possibilities are there. I will talk about those possibilities later, but I think first of all, we need to think about its this number's divisibility by 8 as well. Now, how do I check that? The number was 18601x 57y. Now, we know 2 to the power 1 is 2, 2 to the power 2 is 4, and 2 cube is 8. Now, why did I discuss it? Now, please pay attention to this. Whenever the power is 1, it means I need to check the unit digit. For example, if I want to check a number is divisible by 2 or not, I need to check its unit digit. If its unit digit is divisible by 2, the entire number will also be divisible by 2. If a number's last two digits are divisible by 4, then the entire number will be divisible by 4. Similarly, if a number's last three digits are divisible by 8, then the entire number will also be divisible by 8. By that logic, if I go or proceed here, I need to check that whether this 5, 7, and y, these three digits, whichever number they form, is divisible by 8 or not. So when I'm willing to divide it by 8, I know that 8 into 6, 8 into 7 is 56. So I'm left with remainder 1. So it is 1y. Now 1y should be divisible by 8. It means the only choice for y I have is 6. I hope you are understanding why. I hope you all are understanding it very clearly. Why? Because if it is 6, then only 576 will be divisible by 8, because 8 into 7 is 56. Remainder is 1. That leaves you with 16. So 8 into 2 is 16. So that is how it will be divisible by 8. So I have now clearly understood that the value of y is going to be 6. Now, once you have cracked the value of y, now you're left with the value of x. Now, please understand, this is 1. Y is going to be 6. Now, what value shall I put here so that it becomes a multiple of 9? It should be either 9 or 18 or 27, but I can clearly see, I have, 6 plus 1 is 7. So 7 plus 2 would be 9. If I wish to make it 18, I'll have to make some, better changes, but those changes will not be acceptable. Why am I saying so? Because 6 plus 1 is 7 and 18 minus 7 is 11. So I cannot take the value of x as 11 because x is a digit and it cannot have a two-digit number, because x is a basically digit. I hope you're getting it very clearly. So I have clearly cracked the logic that the value for x is going to be 2 and the value for y is going to be 6. But we were asked the value of x plus y. So 2 plus 6 is going to be 8. However, to solve this entire question, you need not do all this. You need not do all this if you were given the options. Because see, 1 was already cracked. I knew that the number will be 9, 18, or 27, like that. The sum should be. So x plus y could be what? Either 9 minus 1 or 18 minus 1. But to have more clarity that whether it can be 18 or not, I had to check it with 8. I had to check whether this number is divisible by 8 or not. So this is how we'll proceed with this category of questions. So I hope you must have understood a lot of basics, a lot of nuances, that how are these questions cracked? How are these questions understood? For example, this here is a question, another one, which again will give you a lot of clarity on things. Now, what is this question? This question says that you need to look for the largest possible number, which on dividing 85, 150, and 220 leaves a remainder 1, 6, and 4 respectively, which means I don't know that number, but let's say that number which we are looking for is n. So I'm looking for a number which is n for me. So this n, when divides 85, it leaves a remainder 1. This n, when divides 150, leaves you with a remainder 6. The same n, when divides 220, leaves you with a remainder 4. Now, what's the problem here? The problem is simple, that had there not been a 1 here with 85, that number would have been perfectly be divisible by n, which means 84 would be perfectly divisible by n. Similarly, had there been, no excess of 6 with this 150, this number would have been perfectly divisible by n, which means if the number is 144, it would be divisible by n. I hope you're getting the logic why. In the same manner, can I not say that 220 has this excess of 4? Because if I remove that 4, which means if I keep it up to 216 only, then I'll have a number which will be perfectly divisible by n. So in a different language, can I not say that I'm looking for the largest possible number which can divide 84, 144, and 216 completely? I hope you're getting the logic very clearly now. I hope you all have understood that. In short, I'm looking for a number which is the HCF, highest common factor of 84, 144, and 216. Now, there are multiple methods of finding the HCF. I'll share one of the methods which I highly and mostly appreciate. What is that method? This is called long division method. Now, how do we do that? One of the ways is factorizing it, seeing the common factors and taking the highest common factor. So that's how we could have basically cracked it. There are multiple short techniques as well. That means taking the, intersection of the factors, the powers of factors, that also gives you the HCF. So these are the different techniques. But one of the methods is that you do it with the long division method. Now, what does long division method say? See, I have 84 and I have 144. So I'll try dividing 144 by 84. Now, what do I get? I very clearly know if I double 84, I'll get 168, which is way much than this. So if I simply divide 84, here by 84 to one times only, then I'll get a result. So I hope 140 minus 80 is clearly 60. So I'm left with the remainder 60 here. Now what I do is, the next thing which we do is, I divide 84 by 60. I hope you're getting this logic very clearly. So now I'm willing to divide 84 by 60. Now when you divide 84 by 60, what do you get? Again, 60 cannot divide, 60 just have one, 60 should be multiplied with 1 only, because 60 into 2 would have been 120. So here, when you get this, 84 minus 60 leaves you with 14. Sorry, 24. I'm really sorry. So it leaves you with 24 now. Then 24 goes to this 60. Now 24 tries to divide 60. I hope you are understanding how am I proceeding here. First of all, I tried dividing 144 by 84. Then the remainder which I got is dividing this 84. Then the remainder I got is dividing this 60 now. I hope you're understanding it. So this 24 now divides 60. Now 24 when divides 60, what do we get? So 24, double of 24 is 48, I believe, because triple of 24 is 72, which is a little higher than that. So I'll take double of 24, which is 48. Now 60 minus 48, we all know is 12. I hope you know that. And 12 perfectly divides 24. 12 perfectly divides 24. So finally, I've gotten a remainder 0. So the moment you get the remainder 0 is going to give you a little bit hint or a clue about the divisor. Oh, sorry, HCF. So 12 could be the HCF, but I need to check it with the other number as well. So I had one more number, which is 216. So let's check it for 216 as well. So I'll take this number 144 and 216 here. I hope we can do that. Now, I hope you know double of 124 will be 288. That will be too much. So I'll take 144 here. Now, 216 minus 144. So 144 plus 6 is 150. 150 plus 50 is 200. 200 plus 16 is 216. Now, I hope you are understanding how am I doing it. This is called, looking for a number which when added to 144 gives you 216. So I'm not actually subtracting, I'm subtracting through addition. This is the little different method. It actually works. I'm demonstrating it. That's why it may look a little slower or time consuming method. But when you get used to it, when you practice it more, you start realizing that this method is also a very effective one. All I did was I have started thinking that what number should be added to 144 so that it can be converted into 216. So I started with 6, that 144 plus 6 will be 150. 150 plus, this is all what you need to do mentally, but to demonstrate it, to make you understand all of this, I am doing it on paper, on this sheet, on this screen. So that 50 takes it to 200, and then 200 plus 16 will take it to 216. Now 50 plus 16 is 66, 60 plus 6 is 72. So I'm left with 72. Now 72 when divides 144, I think I need not tell you that double of 72 will be 144. So here I'm able to divide it completely with the help of 72. So from here I could get 12, from here I could get 72. Now I need to work out between 12 and 72. So I think I very clearly know that 12 into 6 is clearly how much? Nothing but 72. So yes, this 12 is going to be the HCF. And if we have cracked that, that 12 is going to be the HCF, which means 12 is that number which when divides 85 leaves you with 1, which when divides 150 leaves you with 6, which when divides 220 leaves you with 4. And this is the largest possible number. It is mathematically impossible to figure out a number greater than 12 which will do this. So I hope you're able to develop the sense that aptitude is simple maths, easy maths, basic maths. All you need to have is the basic understanding of numbers, the concepts which you have studied up till 10 standards. So questions are going to be easy, simple. You just need to read them, develop the logic, develop the sense, and then you can solve those questions very simply, very easily. For example, here, if you look at this question, what does it say? It says, n is a number that on being divided by 3, 4, 6 leaves remainder of 2 in each case. Now, the first question or the only question we have is, find the smallest 3-digit value that n can assume. Now, how do we think of that? Forget the entire question. Let me think of it in this manner, that I'm looking for a number which is divided by 3, 4, and 6. So first of all, let's forget about this remainder. Let's think of a number which is divisible by 3, 4, and 6. So can I think of a number which is divisible by 3 as well as 4 as well as 6? So I think the number which I'm trying to have here is nothing but the LCM of 3, 4, and 6. And we all know LCM of 3, 4, and 6 is going to be 12. I hope we all know this very clearly. If you don't know how to do it, so if you prime factorize 3, it is 3 to the power 1. If you prime factorize 4, it is 2 square. If you prime factorize 6, it is 2 to the power 1 into 3 to the power 1. Now, if you start taking the higher powers of the prime factors, so 2 has the power 2, 3 has the power 1. So 2 to the power 2 is 4, 4 into 3 is 12, which is what I have written over here. That is something which you can easily conclude through common sense as well. But this is the standard operating procedure while evaluating the LCM of certain given numbers. Now, 12 I could crack is going to be the number which is divisible by 3, 4, and 6. And 12 is that least number, the smallest possible, which means any multiple of 12 will always be divisible by 3, 4, and 6. So 12, 24, 36, 48, all these numbers will be divisible by 3, 4, and 6. However, they have asked us that, this number should leave a remainder 2 in each case, which means it should be a multiple of 12. Rather, it should be 2 more than the multiple of 12 because I need to have a remainder 2 in each case. So any multiple of 12 will be divisible by 3, 4, and 6. But if I add 2 to it, now it will not be divisible by 3, 4, and 6, and it will always leave a remainder 2. I hope you're getting the reason why. We were not asked this question. What we were asked was find the smallest 3-digit value that n can assume. Now, how can I think of the smallest 3-digit value? Now, how will I do it? Let me try and think of the smallest 3-digit number. So I think 100 is that smallest 3-digit number. So 100 is that smallest 3-digit number, but I think 100 does not fall under that category. So if I trace the table of 12 up till or around 100, I think 12, goes around, as we have already discussed, 72. Then after 72, we have 84. Then we have 96. Please pay attention to this. After 96, what we have, 96 plus 10 is 106, plus 2 is 108. So the next number you receive is 108. Now, please pay attention. This 108 is that smallest 3-digit number, which is divisible by 3, 4, and 6. But I don't need this 108. I need 108 plus 2 because I need a remainder 2. So my answer would have been 110. Did you all get my statement, students? Why did I say that 110 will be the final answer to this question? So I hope you all are able to understand and digest how easy these questions are if you know the language, if you can crack the code and easily bring up the data which is needed. Again, let's get more clarity on this category of questions with this example. I'd request all the participants to pay attention to this question. What does it say? Let's have a look at that. So there is a school. It has 120, 192, and 144 students enrolled for its science, arts, and commerce courses. There are 3 courses: science, arts, and commerce. And there are how many students? In science, there are 120. In arts, there are 192. And in commerce, there are 144 students. Now pay attention to this part, student. What does the language say? All students have to be seated in rooms for an exam such that each room has students of only the same course, and also all rooms have equal number of students. So what is the least number of rooms that is needed? Of course, one could have said, sir, let's say, in each room you make one student sit. So 120 rooms will be required for science students, 192 rooms will be required for art students, and 144 rooms will be required for commerce students. But that is not what they are asking. What they are already or also giving you as a constraint here is that the number of rooms should be least. Please understand, the number of rooms are going to be least. If the numbers of rooms are going to be least, there is one more condition, that if this is a room, only students from only one stream can sit. So it could be either science, arts, or commerce. So a room cannot have students from different streams or multiple streams. The second condition is the number of students in each room should be same. So if there are 4 students in one room, every single room should have the same number of students. Now, how do we do this? Do you not think that whenever this category of questions are asked, what they're internally trying to ask us is that you need to think of a number, the largest possible number, which can divide 192, 120, and 144. Because when you try to think of a number which is the largest possible number, which can divide 192, 120, and 144, then you're ensuring that 120 is perfectly divisible by that number, 192 is also perfectly divisible by that number, and 144 is also perfectly divisible by that number. Which means that will be the number which is going to give you the idea that these many students are going to sit in each single room. First of all, I hope you are developing that sense. Along with that, I can also clearly say that that is going to give you the idea on the least number of rooms, because you have maximized the number of students. You have maximized the number of students which can be catered in one room. I hope you are understanding the language very clearly here. So in short, I need to look for a number which can divide 120, 192, and 144. You can opt for either, this long division method or some other methods as well. For example, one of the methods could be, let's say, 120. So what is 120? I hope you all know that 120, I hope I'm very clearly visible and audible to all the participants. So 120 can be treated as 12 into 10. So 12 into 10, I can treat it like this, 12 into 10. Or 12 is basically 4 into 3. So 12 is 4 into 3, and 10 is basically 2 into 5. So 120, I could have written as, 2 to the power 3. I hope you're understanding y into 3 to the power 1 into 5 to the power 1. What about 192 students? So when you talk about 192, how do I split 192? So if you know the tables, you can very easily crack it. For example, I think 160 plus 32 is 192, which means this is divisible by 16. I hope you're understanding why. So yes, so this is basically nothing but what? 16 into 12, I believe. How did I do that? Because I know 160 into 10 is 160, and sorry, 16 into 10 is 160, and 16 into 2 is 32. So 160 plus 32 is 192. That's why I'm concluding that it is 16 into 12. 16 we all know is 4 square. 12 is 4 into 3. So from here, 4 cube, 4 is basically 2 square. So 2 square to the power 3 is basically 2 to the power 6 into 3 to the power 1. Now I need to crack 144. 144 is a very simple phenomena here, because it is going to be 12 into 12. 12 we all know is nothing but what? 4 into 3. So 4 into 3 means what? 2 square into 3. And this entire thing needs to be squared. With this, I get the idea or sense that it is going to be 2 to the power 4 into 3 square. Now, how do you find the HCF? In LCM, we look for the higher powers. But in HCF, we look for the lower powers. For example, 2 has the least power 3 here, because 6 and 4 are greater. 3 has the least power 1 here, because 2 is greater. 5 does not have the least power 1, because as you can see, there is no 5 here. So the least power of 5 is 0. So the LCM here is going to be 2 to the power 3. Sorry, HCF here is going to be 2 to the power 3 into 3 to the power 1. 2 to the power 3 into 3 to the power 1 gives you nothing but what? 8 into 3, which leaves you with 24. So your HCF is going to be 24 here. Now, 24 is not the answer. Please understand, first of all, 24 is the number which can divide 120 as well as 192 and 144. Along with this, 24 is that largest possible number which can divide all of these three numbers simultaneously, which means mathematically there is no number which is greater than 24 which can divide all of these three numbers simultaneously. Now, what's the problem here? The question was, what is the least number of rooms required? Now, least number of rooms required means what? 120 plus 192 plus 144 is the total number of students I am having, and each class can have 24 students. So total number of students divided by the number of students a class can cater will give you the number of students can be catered in one class. Or if you are not able to get this part from here, you could have done it from here. See, 24 when divides 120, what are you left with? I think you're left with 5 from here. I hope you are getting it very clear. 24 when divides this, I hope you're getting it very clearly. What are you going to be left with is 2 cube only. And 2 cube gives you 8 from here. I hope you're understanding. 24 when divides this part, 2 cube is eliminated from here. You're left with 2. And 3 is eliminated from here. So you're left with 3. So 3 into 2 is 6. So 5 plus 6 is 11. And 11 plus 8 is 19. And I think 19 is given to us in the option B. So I hope you're developing a clear sense that how are things happening and how you should proceed with this category of questions. Meanwhile, while we are discussing all of this, I hope you're not forgetting that Nata and JE2 crash batches are already started. They are classroom as well as online classes. So whichever format is visible and convenient for you, you can opt for it. You can attend the offline classes along with this. You can go for the online classes as well if it is more convenient for you. Admissions are open. You can always contact us on this given number 8086 111 044. We have our centers in different cities. You can always approach us. So the dates of starting these batches are 24th of March, 26th of March, and 31st of March. But of course, you can always contact us. You can always stay in touch with us, and you can always, approach us for all the queries and concerns you have regarding NATA or GE Paper 2 for B.ARCH or B.TEST. Now, let's get back to all what we have discussed so far so that you get complete clarity on this particular session. First of all, if I take you through this question was basically based on divisibility rules. So you should be aware of now what you should all know whenever it comes to talk about aptitude. So you should be aware of divisibility rule. That means you should know that when or how a number is ensured that it is divisible by a given number. Along with that, if there are composite numbers, for example, 24, how do you develop a rule, divisibility rule for it? So you basically divide this number into two numbers which are co-prime to each other. And then if a number is divisible by 8 and 3 both, that number will be divisible by 24. Because 8 and 3 are co-prime for each other. Because the HCM of 8 and 3 is 1. That means 8 and 3 are co-prime. Similarly, we had discussed another category of questions where we were asked to, find a number which can divide these numbers, but it should leave a certain remainder in each case, a different remainder respectively in each case. Here, we could simply develop the logic that 85 should not have 1, 150 should not have 6, and 220 should not have 4. That means these numbers were there, which were supposed to be divisible by a certain largest possible number. And there we developed the concept of finding the HCF. Along with this, we have discussed two methods on finding the HCF. One of the methods was this, where we, used prime factorization, the lowest power, the most common powers of, prime factors were discussed. And through this, we could find the HCF. Along with this, there is this long division method. I hope this also must have been understood by all the participants that there are two methods basically. There can be more methods, depends on the trainer, but these two methods which I genuinely and highly appreciate can be used while finding out while to find out the HCF of given numbers. Along with that, yes, there was a question based on LCM as well. So yes, I hope you know how to find the LCM. We have taken a very simple example. So this is how we are supposed to do things. So I hope you are getting this complete clarity that what all we are going to offer you in these classes, in these courses. So this was a marathon session where we have discussed architectural awareness, drawing, and Nata based aptitude. For more details, for more concerns and queries, you can always post your concerns in the chat box as well. Our team would definitely love to answer those queries. With that, I believe we can call it a day here. I think I've tried giving you a lot of clarity. Thank you so much, students. You have been a great audience. Thank you so much, everyone. Calling it a day here.